let's check. Freeze grading. Formal grading. Only 5 people missed, so good. So people are working hard to prepare for the exam. That's good. In 404 is always more prepared than in 304. That's good. And this one, about 5 people, you have to really study harder. Yeah. So this is present value, so you don't have to do anything, but you have to make all those one to present value, right? WACC is 10%, so 400 divided by 1.1, 36364. And 800 divided by 1.1 divided by 1.1, 66116. And I think that's enough because what? It's only minus 500. To save your time, you don't have to do this one. Why? This is more than 500. 363 plus 661. That is more than 500. So you to save your time, you don't have to get present value of this one, right? So 500 minus 363.64. So I'll just store this one at 1 to save time. And 500 minus 363.64, 130, then 136, 36. So it took whole year. So 1 plus the next year is not the whole year. So 136, 500. 136.36 over 661.16. So that one divided by, we call 1.21. So 1.21 years, right? So that is the answer, 1.21 years. So, yeah, this is not difficult. All you have to do is just change to present value, right? But if this is not bigger than 500, this 2, then what? You have to get present value of this one too. Then what? 100 future value, 3n, 10 IY, hit present value, right? But this time you don't have to do that. So that is quiz. Then let's just continue our chapter 12 concepts. So as you know, the IRRs are the big problem. So there's no IRR. This is no IRR, right? No IRR. This is just one IRR. Then 1, 2, 3, 4 IRRs. And here is what? 1, 2, 3, 4, 5, 7 IRRs. So the maximum number based on sign change. So conclusion is that if there is more than one IRR or there is no IRR, then definitely your IRR method doesn't work. That's a big problem. But I told you that managers like IRR method. They're pretty simple, right? Return of the project compared to your company's cost of capital. Return of the project is bigger than cost of capital, take it. More than cost of capital, reject it. And again, same thing. If return of the project is same as your cost of capital, then you take it. The cost of capital is your bottom line. So that satisfies, the project satisfy your requirement, so that's fine. So projects IRR greater or equal to your cost of capital, you take it. If not, reject. So that's easy. But as you see, those problems there, so IRR may not work. So the managers went to professors and what should I do? I want to use IRR. And professors recommended modified internal rate of return. M is modified, and IRR. Then how they modify? That is, it's like this. You just kind of correct some problems of IRR. That is what. If there is more than one sign change, then what? Then IRR doesn't work. Then what? First thing is, how about just making just one sign change? Then what? Making one sign change means what? You collect all the negative cash flows, like if you have like 0, 1, 2, 3, 4, so minus, plus, minus, plus, minus, something like that. Then what? Then you collect all negative to present, and all positive to the end. Then what? You have a negative cash flow in time 0 and positive cash flow in time 4. And some people say that this is negative, so the negative negative goes to 0, then there's nothing. So how about 3 is the end? No, that's wrong, because this is a 4-year project. So end of the project is year 4. So all positive numbers go to the end. So there is one negative in time 0 and one positive in time 4. So what? One sign change, minus to plus. So there will be only one IRR. So this one definitely solves the problem of multiple IRR or no IRR. Then what? Then the second step is when you move those cash flows to the present or move those cash flows to the end, right? What discount rate and compound rate you use? That is what? That is WACC. So, IRR assumes that reinvestment rate is IRR, right? That's a wrong assumption, right? So MIRR corrects 2 ways. One is what? Only one sign change. And when you move those cash flows, you use WACC to compound or discount by WACC. So MIRR assumes cash flows are reinvested at WACC. And MIRR is the discount rate, which causes the present value project's terminal value equal to present value of cost, right? So that is what? That is basically net present value. That means what? Net present value equals 0. Terminal value present value of terminal value equals present value cost. So net present value equals 0. So MIRR is definitely IRR, right? But to improvement, only one sign change and compound discount by WACC. So given that foundation, let's calculate MIRR. So when you see this one, we have a negative cash flow, but there is a negative cash flow again, right? Then, and this is positive. So negative cash flow, you have to move back to current time 0. Using what? Using cost of capital, WACC. So this is like 60, this is 60 divided by, let's use a little bit thicker, 60 60 divided by 1.1 squared, right? But there is minus, so you keep minus. And then this one, this 10 should be in time 3. So from 1 to 3, there are two periods. So 10 times 1.1 squared, 4.1, right? So 190 plus 12.1, and 202.1, 202.1, right? 202.1. So you now this is your 3 value and this is your 3 value. So you add them up, right? Then 202.1, and you move all negative to present. So you add these two minus 149.59. So final cash flow will be like this: 0, 1, 2, 3. Where 149.59 and 0, 0. And 202.1. So if you use cash flow 149.59 negative, enter. C1 is 0. See, so F should be 1, right? 1 enter, it's like this. Or you can add 0 enter like this, then what? F is automatically 1. And C3, 202.1. We go to IRR, compute, 10.55%, right? Oh, how would you get this one faster? Anybody? How would you get this one faster? Given your time value of money knowledge. Because this one
using NPV?
NPV is dollar, so you have to calculate return. So this is basically saying that you invest 149.59 and you get 202.1. So how do that? How would you calculate IRR? Faster than the one I did. Anybody? So you have to know how to apply your knowledge. You know it already. Nobody? Hint is that you know it already. Okay, that is this. Simply, you invest, that is present value. And 202.1 is future value. It took 3 years, 3N. And so for IY. So, second, clear TVM, 149.59 negative present value. And 202.1 future value. 3 years, 3N. And compute IY, 10.55. So that means what? Now you know that IRR is nothing more than rate of return, right? Rate of return, right? And this one is easy. Just you don't have to use IRR. You don't have to use cash flow. Okay, from 0 to 3. So there's nothing there. You don't have to enter entering cash flows here, right? So just present value, future value, 3N. So this is faster way, right? But we now know that IRR is nothing more than just return. But difference from return is that IRR is just more like just magnitude. There's no direction in that. Now, when you say return, you know the return, right? When you make money, return is positive. When you pay money, return is negative. There is cost, right? You know that, but IRR, you just don't know, just the magnitude. So that is how to calculate MIRR. So MIRR is not difficult. All you have to do is change all negative cash flows to the present and change all interim cash flow, positive cash flows to the end. As I said, if the last cash flow is negative, then what? When you move this negative to the present, there's nothing there, but still you have to move a positive cash flow to year 4, right? Very important. Because this is a 4-year project, not 3-year project. So you have to move it to year 4.
So Professor, could you do that again? Could you do that again? I'm getting 10.59.
That's strange. The second clear TBM, 149.59, right? Negative present value. 202.1 future value. 3N and compute IY 10.55, right?
Okay, you got that now.
But okay, yeah. So believe it or not, this one, if this is on the exam, many people miss. I don't know why. Maybe you need lots of practice. So just as you just mentioned, yeah, you need lots of practice. So even homework problems, people make mistake. So 10, like you have to. So this one is what? 10 present value, 10 IY, and 2N, and hit future value. The same as this one, right? And this one, same thing, right? 60 future value, 2N, 10 IY, and hit present value. Do it those things for all the other cash flows, and just make negative cash flow front, positive cash flow at the end, and calculate IY. That's it. So that is actually better than IRR, right? If you calculate MIRR, then what? You can always have just return. And that is definitely better than IRR. But it's not better than net present value. We'll talk about that later. And the next one is profitability index, PI. PI is present value of cash inflows divided by present value of cash outflows. So present value of inflows over present value of outflows, then what? Bang for the buck. So you say like your $1 investment, how much they generate on average, the return? What is the multiple? Something like that. So that is basically profit over cost, some kinds of inflows, cash inflows, cash outflows. So if we use this one, Project L, right? Look at this. There is no negative cash flows here, right? So the important, very, very important thing, when you calculate profitability index, you have to separate negative cash flow and positive cash flows, right? Don't mix that. Net present value, you mix that, right? You mix negative cash flow plus positive cash flow and look at the net result, right? A profitability index, you have to separate negative cash flow and positive cash flows. So there is no negative cash flow, only positive ones, right? So positive ones, again, present value is 10 divided by 1.1, 60 divided by 1.1 squared, and 80 divided by 1.1 cubed. But it's better for you to use your technology, right? Cash flow. Let's check. Oh, good. Step 0 is 0, right? You put 0 here, why? Because we separate negative cash flow and positive cash flow. So make sure that you clear work. And C1 is 10. C2 is 60. C3 is 80. And go to MPB. I is 10. Compute. 118.79, 118.78. So this is more accurate. 78 is more accurate because this one you use dollars and cents, so it's some rounding up. So calculator is more accurate. So 118.78 or 79. But as I said, if you write down like this and 79, that's fine. Yeah. And then what? Then present value of cash inflows or present value of cash outflows. In this case, you don't put negative here. Just outflows is outflow, right? So just both are positive here. So it's PI is not negative, it's just positive. So 108.69 over 100, no, 1.1879, right? And I ask you to have 2 decimals, so it's 1.19. Yeah. Then, what is property index of S? You know, that is easy too, right? That we have project S minus 100, 1, 2, 3. Project S is we use 70, 50, 20, right? 70, 50, 20. So what is PI of S? Okay, for fun, just I have the answer here. What is PI of S?
Professor, I have a question.
Question? What is that?
Yeah, how did you determine the $100 outflow?
Oh, that is sorry. This is project S, and project L is what, like this. This is we are just continuing same project. So that is 10, 60, 80. Thank you for asking. Yeah, I'm not talking about new project. This is a project we've been talking about. So minus 100 is given, okay? The project is given like this. Then what? Then we separate negative cash flow and positive cash flow. So you have only positive cash flow is present value cash inflows. And outflow is investment, 100, right? 100. Okay, yeah, good question. Yeah, clarifying question. I'm talking about.
When I did the cash flows, the answer I got for NPV is 118.7829. How did you round that up to 79? 118.79.
118.79?
Yeah, because I got 118.7829.
7829. 7829. Then 78, right? 78.
Yeah, but on your answer, you got 118.79 for your cash flows.
Look at this, 118. Let's check. Yeah, 118.78. 78.
Oh,
Yeah, this one, I told you that this is correct, but 79 is because of carrying dollars and cents, right? So they are rounding up. Okay. Yeah. Okay. Thank you for asking. Yeah, that's clarification. Then Who get PI of S?
I got it.
I got it.
173. 1.73.
1 point.
73.
Oh, that's too big.
I got
What's the
1.199.
Check. Where is 1.199? That is what? 1.20. Yeah, dollar at 2 decimals, 1.20, right? So
Can we do
Yeah.
it, please?
let's do it then. So I think cash flow. So we use this one, right? So CF0 is 0. C1 is 70. The same time, so I didn't clear. So I think it's same thing, 70. And C2 is 50. And C3 is 20, right? And go to MPV. I is 10. Compute. 11998. So that is 11998 over 100. So that is 1.199. That is 1.20. Yeah, 2 decimals. So just that's why you need to practice. You know the concept, but if you don't practice in the exam, I think you make a mistake. So please practice. Then the question is this: we have this. So we'll talk about project L, right? Project is 106080 again. Minus 100, 10, 60, 80. But if C1 is minus, right? So this is L prime, so it's not L, so project L prime. Then for fun, what should be PI? So you know how to do it now, right? So you have to separate minus cash flows and positive cash flows. And then present value of cash inflows over present value of cash outflows. So cost benefit analysis. Present value of benefit over present value of cost. It won't take much. Anybody calculate PI? So to save time, you just let me know if you have the answer. You can stop me anytime. As I said, well, what do you get?
1.1 rounded.
1.1,
01.
1.01, check, good answer. So what did you do?
I just took the present value of -10 and then got 109.09 after adding it to -100. And then took the present value of year 2 and 3, added them, and then divided the inflows by the outflows.
Good answer. Oops. Good answer. That's good. So all you have to do is just separate negative cash flow and positive cash flow, but don't use negative, okay? Just negative cash flow is 110, right? And positive cash flows are 0, 0, and 60. Oh. 0, 0, and 60, and 80, like this, right? So you have positive cash flows, 2 and 3, and negative cash flows, 0 and 1. So this one, you can exactly just present value of 10 is what? 10 over 1.1, 9.09. Then 100 plus 9.09 is 109.09. And this one, just you can get present value this one using your technology, right? CF. CF 0 is 0. C1 is 0, right? 0 enter. And C2 is 60. C3 is 80. Put NPV. 10. Enter, down arrow. Compute. 109.69. So this NPV is 109.69. So PI is present value of pipe cash flow 109.69 over 109.09. 109.69, you can hit C/C, then what? You salvage this number and divide by 109.09, 1.01. So that's the answer, 1.01. So what do you think? What should be the decision rule for PI? If you use PI, what should be the decision rule?
Okay, I have a question, Professor. So you have to move the negative to the present as well?
Yeah, negative to present. This is 10 is 0. So that's what this is what you did. 10 divided by 1.1. You discount to 10. You cannot just move 10. You cannot 10 plus 10. No, 10 should be present value. So 10 divided 1.1 is 909. So 100 plus 909 is 109.09. Right?
Got it. Oh,
Okay.
okay.
Good.
Oh, I
Okay.
thought because I thought the outflow doesn't have to be discount, so I just keep 100. That's why.
Oh, I see. So the outflow should be discounted too. Yeah, discount, 100 is already present value, right? So you don't have to do anything. But this 10 is not present value, your own value. So you have to discount one period to get present value. There's 909. Yeah. Then you add them up. So let me get back to my question. So what should be the decision rule, decision criteria to select based on PI? What do you think?
Is it if it's greater than 1?
Check. So decision rule is PI greater or equal to 1, take the project. Of course, PI is less than 1, reject the project. Of course, this is for independent projects, right? Independent. How about among mutually exclusive projects? What should be the decision rule? Among mutually exclusive projects.
Using NPV?
Oh no, using PI. I mean, using PI, what should be the decision rule?
Take the one that's higher PI.
Check. The PI that is the highest. So, but PI, the minimum requirement is what? PI has to be greater than 1. If there are 5 projects, but all the PI is less than 1, then what? Your answer is none. Okay. So some people think that mutually exclusive, you have to choose 1. No, you can choose 1 only when that's profitable. So the bottom line is PI has to be greater or equal to 1. And then among those ones, you pick the highest PI for mutually exclusive projects. Okay, so this one also, many people miss this one, but CF is -10. Some people have trouble calculating this one. So practice. Then the next one is this one, more applied one. That is, you have 2 projects, Project S and Project L. Now, this is not small and large. This S is short, L is long. This 2-year project has a bigger cash flow. Project L, 4-year project, but smaller cash flows. And if you calculate net present value of S is only 41,000, but L is 61,600, almost 62,000, 6,200. Based on your current knowledge, what project should you choose?
L.
L, right? Because L has higher NPV. But the question is here, but is L better? That's the question. But is L better? Yeah. Actually, the answer is no. Why? For you to do project S just once, project L just once, you can do project S twice, right? So like this. Note that project S could be repeated. This is repeatability. That should be assumed, right? If you cannot repeat project S, then this one doesn't apply. But we assume that the project can be repeated. Then what? Then another 2 years, they can generate additional profits. So use replacement chain approach to put on common life. Just like this. That is, look at this year 2. Year 2 is end of second period, and also what? Beginning of third period. So year 2 has that meaning, end of second period, but also beginning of the third period. So same time. So you have $60 in year 1 and year 2, but year 2 you start a new project. Same project again, 100 project S, invest, and then what? 60. So it's like non-normal project. Negative cash flow, positive cash flow, negative and positive and positive. But net present value calculation, no problem. So you have what? 7,547. Huge. So the right answer is choose project S and do it again, right? So 2 times a year, 2 times in 4 years. A project L, you can have only 1 time in a 4-year project, right? So net present value, considering common life, that is 4 years, net present value of S doing twice is better. So you choose S and repeat. So you can do like this, or if you do it again in year 2, if you calculate, if you had calculated NPV, then what? You can use NPV, same NPV here, but that's year 2 value. So you discount for 2 years, and you get this one, same thing, same approach, right? Either way, this way or this way generate same net present value like this, right? Because you will get this one today, and after 2 years, if you repeat the same net present value in year 2, but that 4132 is year 2 value, so you have discount to the present, and you get net present value of doing it 2 times, and you compare that to project L's NPV 6190. Well, this one is a lot bigger, so you choose project S and do it twice.
Professor?
Yep.
Would you be able to do an MIRR calculation on that replacement chain cash flow, just to get another look at it?
That's kind of like a brilliant question. So you mean MIRR?
Yeah.
That's a good idea. Okay, that's a really good idea. So it's like this. So if you write down this cash flow, minus 100, year 1, 60, year 2, minus 40, year 3, 60, year 4, 60, right? So you have to move negative to the present, right? And this is already year 4, so you don't have to do anything about that. But this one is year 3, so move it to year 4. And this one is year 1, so move it to year 4, right? So first, let's get present value of 40 using just technology. Second, clear TBM. 40 future value, 2N, right, 2 year, and 10 IY, and compute present value, 3306. So that is, let's use it different color. 33, so here, 33, oops. Let's just use same color, 33.06, but that's negative. So minus 133.06. Then this one, easy one, is 60 times 1.1 is 66. But this one is 1, 2, this one is 3 year, right? So using our technology, 60 present value, 3N, 3 year, from 1 to 4 is 3 year, 3N, and 10 IY, and compute future value, 7986. So this one is 60 times 1.1 cubed is 7986. So if you add all three, 60 plus 66 plus 7983. So if you clear TBM and change it sign, then 7986 plus 66 plus 60, then what? 205.86. 205.86. So now it's like this. At time 0, minus 133.06, and time 4, 205.86. So using our technology, second clear TBM, this is future value, and 133.06 negative is present value. And 4 year, 4N, compute IY, 11.53%. So we know that this project's MIRR is 11.53%. That's greater than your 10%, so you take it. Then what? Then how about, since you asked, let's just get IRR of S. IRR of S is that cash flow. $33.5. F is 4, or enter. IRR. Compute 12.83%. Right? So according to IRR, S is better, right? But that is consistent with net present value technique, right? Replacement chain approach. replacement chain approach, you get, you have a high NPV, but MIRR is 1153. Why is pretty low? That's the problem of MIRR, right? That's a really good point. Let me check. Let me do it one more time. 133.06 negative present value. 205.86, which value? 4 and compute IY. Still 11.53.
Because you're not including one of the time periods isn't included. You only did 60 times 1.1 and 60 times 1.1 to the third and 66 plus 79.86. That math doesn't make sense.
60, there are 360s, right? 360s.
Oh, you're adding that fourth one? There's, okay, so you didn't put 60 on top of that. Okay, I see now.
Yeah, so 60 plus 66 plus 79.86 is 205.86, right? So that is like future value. So MIRR is pretty low. So actually, that's the problem of MIRR. Yeah, that is what. NPV wise, this way should give you. This way means what? Replacement chain should give you the highest IRR, right? So MIRR is definitely not IRR, and this MIRR is relatively low compared to other ones, even lower than just a long project when net present value is highest. MIRR is just, so MIRR just shows you whether it is consistent with net present value in terms of whether you take the project or not, but may not be used to choose which one to choose, right? Because according to MIRR, this project is doing as twice is the worst, right? Compared to, look at this, 13.07, 12.83, but this one, 11.53, that's really strange.
Are you sure that 205 is correct?
105 is correct, right?
Well, I don't know. I did the cash flow function on the calculator, and I didn't include the negative 100 for cash or for year 0 and then negative 40 for year 2, and I got a different answer.
60 divided by 1.1 isn't 66. It's 54.55. You're multiplying, right? So why are you multiplying? I thought you were dividing.
No, dividing is dividing 40. You are right. You are right.
Yeah, you multiply.
Yeah. 40 has to be 2 times, right? That's why. Yeah. So sorry. So 40 is year 2. I see. That's why. Sorry. Year 2, 40 divided by 1.1 divided by 1.1. 33. That's correct. 33.
No,
Two
it's
times.
on the right side, you have 60 times 1.1. It's supposed to be divided by, and then you have 60 times 1.1 cubed. It's supposed to be divided by 1.1 cubed.
No. This is compounding. So 60 should grow. If you go right direction is compounding. So year 3 value is 60, then year 1 value has to be 66, right? The 1 value has to be 66. And that's pretty strange, by the way. So the calculation is correct, right? Let me check one more time. 60 plus 66 plus 79.86. 12,586, yeah. 60 times 1.1 is 66, right? And 60 times 1.1 cubed, 7986. So that's pretty strange. 1.1 by x3, like this, times 60. Yeah, 7986. So I did everything correctly, but MIR is only 11.53%. So, sometimes using MIR, they give you wrong answer, right? So that's the problem. So NPV rule is the best. I think that's a really good point. Yeah, we check MIR of this replication project, and MIR is, in fact, pretty low.
Question, Professor. So if it's NPV is the best, why are we studying MIRR or IRR?
Oh, that's a good question. I'll ask that question at the end. Yeah, good point. Good point. Okay. So that one is really kind of interesting, very interesting. So MIRR is sometimes gives a wrong kind of conclusion, right? So for example, if you calculate MIRR of 3 projects, doing twice is the lowest. So it's pretty strange. Yeah, pretty strange. Yeah.
Wait,
But-
Professor,
so-
what did you
yeah.
get for the cash flow for year 4?
Year 4 cash flow is 60. Yeah.
No, like when you calculated the compounding.
Yeah. So there are 3 60s, right? 1, 2, 3, right? So first one is 60, it's year 4, so nothing happens. But 60, year 3, 60 becomes 66. And year 1, 60 becomes 7986. All future values of 60s. Then you add them up, 20586. And a present value of 40 is 33.06. So 133.06.
No, I'm asking like what was the actual value you got for year 4 when you're doing that calculation?
Actual value, what do you mean actual value?
So like in year 4, when you did 60 times 1.1 to the 4th?
No fourth, 3.
Oh,
Yeah, third cube, because from year 1 to year 4 is what? 3 years, so cube, right?
but wait, why are you starting on year 1 again?
Year 1 is positive number. Positive number has to move to year 4. All the positive numbers should move to the end of the project.
Okay.
So from 1 to 4, 3 years. So that's a really good question. So that's the one problem of MIRR. Sometimes when you compare this non-normal project with so those ones are normal project, right? Normal project. Those ones are normal projects, one sign change, right? But this one is non-normal project, right? More than one sign change. In that case, the comparison may be misleading. So it's like, So MIRR is just something that you use if you stick to an IRR method, right? So that's one problem of IRR. Yeah.
Wait, I'm confused still. So for year one, where it's 60, did you multiply it by 1.1 or did you leave it at 60 for year one? What did you do?
Year one, as I said, the positive cash flows should move that to the end of the project.
I get that, but what did you do to year one? Did you multiply it by 1.1 or did you leave it at 60? If it's moving to the end.
This one? You're talking about this one? 60, this one?
What's this one? You don't have like a cursor.
Okay. So this one.
Yes.
This one is year one value, right?
So did it say at 60 or did you multiply it by 1.1?
So you compound this one for 3 years. So this one. 6 times 1.1 cube.
So year 4 is the one that stayed at 60 then?
Yeah, exactly. The 60 is that's a year 4 value. So it is 60. Yep.
Okay, that makes sense. Thank you.
Thank you for asking. Yeah, that is a clarifying question. Okay, so let's just continue. Then what? So this 2-year project and 4-year project comparison is relatively easy, right? But how would you compare 3-year project and 4-year project? 3-year project and 4-year project. Three-year project and 4-year project. Can you compare 3-year project and 4-year project?
You can compare the NPVs?
How? Because they have different life. You cannot directly compare a 3-year project with a 4-year project, right? Like you cannot compare 2-year projects NPV with 4-year projects NPV, right? And how can you compare 3-year project and 4-year project?
Replicate the 3 4 times and the 4 3 times?
Check. Good answer. The common life is 12 years. Then 3-year project 4 times and 4-year project 3 times. And you compare net present value, right? But if one is 10 year, the other one is 11 year, then what? You have to have 110 years, right? Pretty cumbersome. Then what? Then the concept is this. It's like this. So let me show you. Oops, not this one. Project S is that you have 2 years of operation, and the net present value is 4132.23. 4132.23. And project L is 4-year project. And net present value is 6190.49. So S has 4132.23, but only 2 years of operation. L is 6190.49 for 4 years of operation. So the concept is like that. Then what? Then what is per year NPV? That is what? So each year, and you can get per year NPV. How can you get per year NPV? Somebody may say that.
Divide it?
Yeah, like, divide. 4932.23 divided by 2 and 6190.49 divided by 4. The concept is correct, but but that's not correct. Why?
Oh, okay, so I have to discount it. Oh, okay, so divide it first and then move the cash flow in each of the money year, right?
Oh, that's more sophisticated.
Okay.
Actually, you have to take time value of money into account. So actually, the concept is, believe it or not, from 3 or 4, annuity concept. So it's a payment, same payment. That is 2 payments, present value of these 2 payments, that is equal to 4132.23, and present value of 4 payments, that is equal to 6190.49, and that is exactly the definition of annuity. Definition of annuity is like that. So all you have to do is what? Just calculate annuity payment. So project S, 4132.23 present value, 2N, 10 IY, and compute payment. L is same thing, 6190.49 present value, and 4N and 10 IY, and hit payment. Look at this, 4N. So second clear TBM, 4132.23 present value, 2N, 10 IY, compute payment, 2380.95. And second clear TBM, 6190.49 present value, 4N, 10 IY, compute present payment, 1952.92. So getting 4132.23 as a net present value means getting 2380.95 each year. And if you repeat this one infinitely, then what? Every year you will get 2380.95. Project L, getting 6190.49 as net present value means what? Getting 1952.92 each year for 4 years. Then what? If you repeat it, same 1952.92. So definitely this one is easier. You don't have to worry about number of years. Just S is better. S is getting more money each year, 2380.95 forever is better than getting 1952.92. And that is, next slide actually, equivalent annual annuity, EAA, equivalent annual, look at this, annuity, right? So convert the present value into a stream of annuity. So this one, 4132.23 becomes present value, N is 2, I is 10, payment, you get this one. And net present value becomes present value. So everything is same. So here you can just choose S, right? Higher cash flow. Then what? Same procedure applies to annualized cost. Annualized cost. What does that mean? That means it's like this. Machine A has a cost of 3,000, an annual operating expense of 500. and an economic life of 5 years. Machine B has a cost of 5,000, but annual operating cost is less because it's more efficient machine. More expensive, but more efficient. Also, economic life of 8 years. The time value of money is 6%. Which one would you choose? This one is what? Different life too. So it's just like 5 years, but this one is 8 years. So you cannot directly compare, right? So you have to use equivalent annual annuity method to cost just analysis. So it's like this. You just an annual operating cost, that means what? 500 is already annual, right? So you don't have to do anything about that. Already an annual, right? Right? Then what? Then you have to make this investment, okay, 3,000 and 5,000 into annualized cost. So, for example, A, you have 3,000 present value, 5 years, so 5 N, and time value of money 6%, so 6 IY, and compute payment. So second clarity again, 3,000 present value, 5 N, 6 IY, compute payment, 712.19. So this is annualized cost. Then what? Then that plus 500, this 500 is already annualized, right? 1212.19. And then B, 5,000 present value, 8 years, so 8N, 6 IY, and payment, then what? 5,000 present value, 8N, 6 IY is already there, so 805.18. Add 400, that is what? 1205. So let me ask you, which one would you choose?
B.
Sure. You know what? In the exam, somebody calculate correctly and choose A because this is higher than this one. But don't forget that it's cost. So cost, lower cost is better, right? So should choose B, right? Choose B. But believe it or not, some people choose A because a higher number. Okay.
So Professor, I have a question. So for example, like if the annualized cost, like for example, B is lower and A is higher, but the thing is the economic life is like shorter. Would you choose B?
No, everything depends on number. Okay, don't forget.
So you choose like B anyway?
No, what I'm saying is, it is not depends on longer life or shorter life or the whatever. Okay, so you may have intuition that even though cost is high, annual operating expense is low, then that's better. No, it all depends on numbers, right? For example, if I change has a cost of instead of 5,000, if I make it 5,500, then what? Then that definitely B will be more expensive, right? So it doesn't depend on whether you use just a machine that runs long or short. It doesn't matter. It depends on number, okay? So if this is on the exam, don't assume that I choose whatever that costs more but run longer and annual operating expense lower is better. Not always. It depends on just numbers, right? It depends on numbers. So you have to calculate annualized total operating cost and then compare. Okay, that's a good question, but that is not, you cannot determine just in finance, you have to just calculate the bottom line, cash flow. Okay. Okay, any other question? So this is very useful, annualized concept. But unfortunately, this one has limit. This one has some problem. That is, the applicability may be limited. Why? Don't forget, everything changes through time. Everything changes through time. Then what? Annualized cost or equivalent to annual annuity assumes that everything stays the same, right? Same cost, same cash flow, but that's not actually real life. 2 years from today, the investment may cost more. Cash inflow can be higher. Who knows, right? So it's pretty rare that every number stay the same, right? So that's the problem of this EAA or annualized cost. So sometimes you may have to rely on replacement chain approach because like it, suppose cost to repeat S in 2 years rises to 105,000 rather than 100, right? So all those numbers are in thousands, so it's 105, right? So in that case, you have to use replacement chain approach. You cannot use equivalent to annual approach, annual annuity approach, because what? The things are different. Same thing as annualized cost, right? So you have to analyze like this. So and of course this may change too, right? But just to make it simple, just we change the cost, then what? Then it will be 45, negative 45, and NPV will be 3415. And that's less than just project L. So now then what? You choose L, right? So this is more like applied. So actually in real life, the use of equivalent annual annuity approach is limited because what? That assumes same condition forever, but that's not real life actually, right? So when you use equivalent annual approach or annualized cost, you have to be careful that so that can be used, right? Like the situation may not change much in the short run, then what? You can use that. But if not, this approach, unfortunately, it takes more time, but this approach should be used, right?
Professor, so where is 45 coming from?
This is 60 is positive, minus 105. So minus 105 plus 60
Okay, got it.
is minus 45. Yep, same thing. Good question. Please ask questions if anything is not clear. And then next topic, some more application problems. Now this is economic life versus physical life. So we call it abandonment option. That is, so far, we assumed that 2-year project, you have to run for 2 years. 4-year project, you have to run for 4 years, right? But if you introduce abandonment option, then things may change. So let's say another project with a 3-year life. If terminated prior to year 3, the machinery will have positive salvage value. Don't forget the salvage value. Should you always operate for the full physical life? So that is very important question. So if there is no abandonment option, such that if you stop the project or if you cancel the contract, then you may have the huge penalty, then you don't have an abandonment option. But if you can terminate the project just without any penalty, then what? Then that is abandonment option. So abandonment option is extremely important and good for your life. So for example, there are some relationship or some kind of group that abandonment option is not there. For example, like gang membership, right? Gang membership. It's hard to abandon the membership, right? Sometimes there is huge beating or even death, right? So you know how important abandonment option is, right? And so one kind of abandonment option is what? Like prepayment. Like if your mortgage, usually you have prepayment option, right? You can prepay. So that what? So that you can refinance, right? But if there is no abandonment option, means what? You get mortgage, but if you prepay, then you have to pay huge penalty. Then what? Then the abandonment option is not there or very difficult, right? So when you make a contract, make sure that you can abandon the contract anytime, right? Without penalty. Like your car loan payment or home mortgage, you have to check prepayment option, something like that. So in the same vein, like this is something, so if this is on the exam, don't ask what this means, right? You have to know what this means. That is what? Year 0, you have your investment is 5,000. And salvage value means what? If you return the machine, there is no penalty for returning your machine, something like that. So salvage value is 5,000. So that there is what? When you invest, but you decide not to do it and you return the machine, then what? You get full refund, 5,000, okay? So that's the case. Then year 1, year 1 means you start your business, and year 1, this is cash flow. But if you stop at year 1, then salvage value of your machine is 3,100. And this, if you run for 2 years, then what? This is your cash flow, and your salvage value is 2,000. But if you run for whole 3 years, then what? Salvage value is 0. So far we have examined this just projects 5,000, 2,100, and 2,000, year 3, 7. So this is actually we've been examining so far, right? And then you just calculate net present value, right? And then net present value according to this one is what? Minus 123. So, oops, what is it? So this one, it's like this. Time 0 is just out of question. So you just, net present value is 0. 5,000, you get 1,000 back, so 0. But you have to examine 1 year operation. 1 year operation is that you invest 5,000 and you get 2,100 cash flow and you get salvage value 31, so 3,100. Then what? The total is 5,200. So this is like invest 5,000 and get 5,200. Then 2 year operation. So you have to do, for this one, you have to do it one by one, everything one by one. Then 5,000 here. And year one, 2,100. Year two, 2,000. Then what? Salvage value, 2,000. Added 2,000. Then 4,000. Then what? Then you have to do it every one by one. So I recommend you, when you solve this problem, either in homework or quiz or exam, just hit cash flow, second click TBA, and you do it from shortest projects first, like this, 5,000 negative, enter. Then C1 is what? 5,200, 5,200. Go to NPV, and 10, enter, down arrow, compute. So NPV is minus 272.73, a negative. So this is not good, okay? 1 year operation is not good. You lose lots of money. Then go to cash flow again to check 2 year, then what? See, 5,000 is already there. And C1 is not, so you change C1. C1 is what? 2,100. And C2 is what? 4,000. Put 10 PV. 10 is already there, down arrow, compute. Suddenly, positive 214.88, positive NPV. But you have to check 3 year cash. So this is already there. C1 is already there, so you save time. But C2 is what? 2,000. 2,000, right? And C3 is what? 1,750. 1,750. Again, down arrow compute. Minus. So until now, you just reject this project. Why? 3 year net present value is negative, so you reject the project. But if you have abandonment option, right, then what? This is what I'm saying. No termination is in thousands, right? Like this. 2 year termination, 2.14. And 3 year termination, 5 years. This is exactly what I did here, right? And then you calculate net present value. 3 year net present value is negative. 1 year net present value is also negative. So the economic life is 2 years. Right? Just like that. So if it is 4 year project, 5 year project, then what? You have to do every year, 1 year operation, 2 year, 3, 4, 5, separately, one by one. And then what? If those are all positive, right? 3 year operation is like 123, let's say, and 215 and 273. Then which project would you, what is the optimal life, economic life?
Three years.
Yeah, 3 years. When those are all positive, then choose the highest one, right? So if this is the case, then what? 2 years. But since this is negative, so you just, year 2 is only positive. 2 year operation is positive. So economic life is 2 years. But many cases, all 1 is negative, 2 is positive. Then you compare the two, the highest number, and that is economic life. So that's not difficult, but you know, in the exam, don't ask me what this means, right? You have to know what this means. Cash flow and salvage value, right?
Okay,
And you
Professor.
could-
So like,
Yeah.
why is the highest number is the 3 years? I'm still confusing.
Yeah, the decision rule is what? Decision rule is NPV is the highest, right? Highest NPV is better, right? So you have to choose highest NPV project. In this case, highest NPV life. Yeah. So that has been consistent so far, right? That's
But-
why.
NPV for year 2 is positive 215. Aren't we gonna choose year 2?
Yeah. This is positive 123, right? But this is positive. But I told you that this is bigger, 273. So just doing 3 years is better than doing 2 years. More net present value, right?
Okay.
So that is how to determine.
Wait, I thought that bottom number was for 1 year though.
Huh? What do you say?
I thought 273 was for 1 year though.
Oh, sorry. You're right. Check. Yeah, it's 1 year. Yeah. I just.
That's why I'm so confused.
Sorry. I thought about 1 to 3, but it's 3 to 1, right? So it's 1 year. Sorry. Yeah.
So it's like 1 year.
Yeah, 1 year. Yeah, because they did it 3 to 1, right? So that should be 1 to 3, but I don't know why. By the way, but the reason they did 3 or 4 is that what? That's what we have been doing, right? Without abandonment option, we think that 3 year is what? The 3 year project, you have to do it for 3 years, right? That's why. Thank you for that. Yeah, this is 1 year. Yeah, 1 year. 1 year. So it's like, I just follow this one, right? Yeah.
So knowing that, we still go with the 1 year option.
Definitely, yeah, definitely. It's highest one.
Okay, so the NPV is like negative. Why are we choosing the smallest? So we have to use the absolute value for the NPV. That doesn't make any sense to me.
If NPVs are positive, so this is different problem.
But they're not positive. So you're saying in this actual scenario, we would use 2 years.
This one, the answer is this. Economics 2. Yeah.
Okay.
So I have to make a different color. Just if.
Thank you.
Thank you for clarifying question. Yeah.
Okay. Now I got it.
Okay. Yeah. Good. See, question is really good. Then next, scale differences. So mutually exclusive projects, right? R is 10%. You are comparing 2 projects. A, 14,000 investment, 5,000, 6,000, 8,000. B, minus 30,000 and 10,000, 14,000, 15,000. Then when you calculate PI, A is 1.11, B is 1.06, A is better. Using IRR, A is 15.58, B is 13.38, still A is better. Using MIRR, A is 13.83, B is 12.31, still A is better. But NPV, A is 1514, B is 1930. In this case, which project would you choose?
Professor, did you say the quiz time today?
Today, no quiz, as I said. The same as the first exam. Okay. Because,
Nice. Okay.
Next class is exam, so I have no time to go over the quiz. So usually the right before the quiz, right before the exam, same happened in midterm exam 1, same thing. Yeah. So, yeah, so we'll finish in 7 minutes. So what do you think? Which one would you choose, A or B? Wrong answer is better than no answer. So just be bold.
A.
A, why?
The PI is higher.
Not only PI, but also IRR and MIR is higher,
MIR,
right?
yes. Mhm.
The 3 versus 1, right? Wrong answer. I told you that NPV is the best. Okay, NPV is, so NPV of B is bigger than that. Why? Look at this. Think about project delta. Project delta means what? Project B already had project A, right? It's bigger size. And you add some project delta. So like project delta is project A minus project B. The project A is bigger than project B. So project B already include project A. So project B minus project A is what? That is delta project. So project A plus project delta is project B. So project delta is project B minus project A. So 30 minus 14 is what? Minus 16,000. 10,000 minus 5,000 is 5,000. 14,000 minus is 8,000. And 15,000 minus 8 is 7,000. So that's why this is delta project. So if you calculate net present value of this delta project, it's positive. So actually, net present value of B is net present value of A plus net present value delta. So actually, by taking B, you not only take A, but also you are taking project delta. And that delta gives you more net present value. So net present value rule is the best, right? So it's pretty clear, right?
So professor, so in this
Yeah.
example, like you use the B, you minus A, right?
So like this.
So project
But-
delta is like project B minus A.
Exactly, yeah.
But
So
why? Because
yeah,
the-
look at
because
this
A is-
equation.
A is bigger than B.
A is smaller.
No, the B is smaller because it's negative 3,000, like 30,000 is like smaller than A. But why do you?
No, this is an investment. So they invest $30,000 compared to $14,000, right? 14,000 investment. So minus is just the direction, your cost. So think about B, your investment is 30,000. A, your investment is 14,000. So actually, B is a lot bigger because you invest more means what? Bigger project. Bigger
Okay,
projects,
okay,
you need
got
more
it.
money,
Got
right?
it.
Good.
Yep.
Good question. Yeah. So you are correct. Minus 30,000 is smaller than minus 14, right? You are correct. So you are like more scientific oriented person. Yeah, you're correct. But this is, don't forget, this is finance. This is management class. So you have to think about, this is just cost. So
Professor, we will always go with the NPV, correct?
No. Yeah, I will talk about that later. Yeah, we'll talk about that later. Yeah. So we will talk about, but here, net present value rule is, in general, net present value is better. But as you asked, 10, I think 10, why, if net present value is the best, why we study IRR, profit margin, profitability index, all those ones, we'll talk about that later. Yeah. And one of them is this, capital rationing. Capital rationing is what? Net present value rule assumes that what? You don't have to worry about money, right? Money is there. Money is there. So you have just you can fund any project that has positive NPV, but that's not real life. Okay? Money is the problem, right? So capital rationing occurs when companies choose not to fund all positive NPV projects. Not to fund or not able to fund. The company typically sets an upper limit on total amount of capital expenditures that it will make in the coming year, right? They have some kind of upper limit, okay? So in other words, they have to think about paying debt or whatever. So they may not be able to fund all the projects. There is some limit. Then what? In that case, bigger net present value project, maybe just bigger project, bigger project will require lots of money, right? In that case, rather than net present value, you may want to go for IRR. High IRR, given limited money, high IRR is better, definitely, right? But I told you that net present value is the best, assuming that there is no money problem, but that's not real life, right? So we'll talk about that more later. Oops, 439. So exam until here. So all 7 quizzes, like exam 1, all 7 quizzes will be on the exam. But definitely with changed numbers, some people miss even quiz problems. That means what? Didn't even go over quizzes. Maybe just look at the quizzes. That's not enough. You have to solve it by hand. Practice. Not only that, you have just other problems, but this is not cumulative. So you have to study from exam 1 up to today, exam until here, from exam 1, right? So exam 2 is not cumulative, but final exam is cumulative, but exam 2 is not cumulative, except, so by its nature, finance, everything is cumulative, right? Except that the content is from exam 1, after exam 1 until today, okay? So study hard, practice hard.
So are you gonna post the answers to the homeworks?
For what, chapter 12?
No, for chapter 10, 11, and 9.
All of the homework, Professor. The correct answer.
Not the homework, yeah. Because, those ones should be for you to practice. You can practice for the original numbers, right? So if I post those ones, that may not be good for next semester. People may copy it. It's not good. So you can just.
But how do we know which one do we did wrong on the previous homework? Because I need to know.
But as I said, that you have to study, you have to practice, But I'll just tell my TA to just show where is wrong. Yeah. Oh, so she may
Hey, Professor.
Yeah. Question.
For the exam, do we just study what the homeworks and the PowerPoints and the quizzes?
So good question. The most important thing is PowerPoint, right? You have to examine all the problems in the PowerPoint. You have to examine all the problems in the PowerPoint. And then the next is your homework. Okay, homework problems, you have to just examine and solve all the homework problems. And your quiz problems, definitely like quiz problems. And then if you have time, just read the book. Yeah, that's how to efficiently. The most efficient one is what? First, review quiz, then review PowerPoint, then review homework, then read the book. Yeah, that's the sequence. Okay. Any other
Alright,
question?
cool. Thanks for answering that.
Okay. Study hard. See you guys.
So none of the material for chapter 12 will really be on the exam, correct?
Chapter 2 is on exam 1, so it's not on the exam 2. Yeah, correct?
No, I said chapter 12.
Chapter 12 is, as I said, exam until here. That means until we cover today.
Okay.
The material until we cover today. Yeah. Okay.
Thank you, Professor.
Thank you. See you guys. Work hard. Okay. Bye-bye.